Infrastructure is the foundation of modern life. Roads, factories, buildings. But every structure starts with materials, and every material has a cost. I recently got married and decided to build a house. But when I started looking into the materials, what they are, how they're made, and what they cost the environment, I realized the problem is much bigger than just my house. Globally, the construction sector generates 34% of all carbon dioxide, more than every car, every plane, every ship on Earth combined. 1 in every 3 tons of waste humanity produces is a building going up or coming down. In Uzbekistan, buildings consume half the country's energy. And with around 200,000 new families forming each year, the demand is growing. Fired brick used to dominate construction, but the government is phasing it out due to its harm. However, the only alternative we have right now is aerated concrete, energy-intensive, built for industrial scale, and requiring $1 million factory. For more than half of Uzbek families living and building outside Tashkent, that's overkill. So we decided to ask, can it be done differently? Yes, a technology called compressed earth blocks that is used in many countries with different climates. You take excavated soil, stabilize it, compress it, and let it cure for 28 days. As a result, you get heat, cold, quake, mold, and fire-safe structures proven for centuries with near zero emissions. But we really needed to have more details.
So we reached out to those who already do this: Dwell Earth and Colorado Earth in the United States, PC Materials in Belgium, Canatectum in Germany, and many others. And now we have technical foundation, recipes, press specifications, quality standards, testing protocols, and other important information. Everything needed to begin production.
But we needed to know what's in people's minds. So we surveyed around 200 people across all regions of Uzbekistan regarding their construction preferences.
Around 80% of the respondents would build their houses from fired bricks, believing they are durable and thermally efficient, yet 65% does not know about its negative impacts. Also, 90% of the respondents have not heard or knows too little about compressed earth blocks. But 85% would be open to use it if they are cheaper, durable, thermally efficient, and looks good.
The good news is, outside of Uzbekistan, this material has already proven all of this. But to make it work here, we needed a partner to guide us through the entire journey.
I've been working in sustainable and green construction for over 20 years in the United States and now in Uzbekistan. When this group of students brought the idea of compressed earth blocks to me, I saw it resonating with the challenges faced by the construction industry here. The technology is proven globally and it aligns well with the traditional construction in Uzbekistan. However, it needs testing, it needs standards and institutional support. Our Green Building Council of Uzbekistan is committed in supporting this team throughout their journey from the concept to grant applications, to pilot projects and stakeholder engagements. Our focus is to make sure this project moves from the idea to reality.
So, where are we? We define a problem that affects both industry and millions of families across Uzbekistan. We choose a proven technology, contacted manufacturers in the United States and Europe, obtained production data, standards and technical specs, surveyed around 200 people to test local perception, and secured backing from the leading institution in the field. The next step is grant application for the pilot. But where will the pilot take place? This is my land, Tashkent region. This is where the pilot happens. We start by testing the soil to determine the right mix. Then we acquire a press and produce the first batch of blocks. Those go to a lab where they get verified against international benchmarks we already have. Next, we design a home around those results. The design works with materials thermal mass, orients the building for solar exposure, and integrates solar systems to reduce bills and dependence on centralized infrastructure. The goal is passive house certification and near net zero energy. Then we build, I move in, and for 12 months I monitor everything personally to understand the full system firsthand. Now, who is this for? Throughout the history, people have built from earth either because it was all they had or because of its performance. This material serves both. For remote communities, this material can be produced on-site without any factory. For those who prioritize performance, compressive strength on par with fired brick, thermal mass that outperforms it, natural humidity regulation, superior sound insulation, and interlocking shape that accelerates construction. All of these, of course, besides dramatically lower carbon footprint. Uzbekistan needs around 55,000 new homes every year. If just 10% were built from compressed earth, that is 70,000 tons of CO2 avoided annually. To absorb that, you would need a forest the size of Samarkand. Each production site creates 4 to 6 local jobs. Solar integration cuts energy bills by up to 60%. And soil that big construction projects currently dump as waste becomes raw material for someone's home. And as the country urbanizes and cities reach these areas, the homes don't become demolition waste. Unfired earth returns to the ground or gets recompressed into new blocks. Full circularity. This is SDG 9 in practice. Rural infrastructure, local manufacturing, greener production, and new research data. And it touches many more. I started this because I needed a home. What we found is a way to build one that gives back more than it takes. We called it Descent. Decent looking, scientifically proven, and self-sufficient housing that descends from the oldest construction material on Earth. Descent. Return to what works.